the viability of the genetically modified red protein being a success?
Well, it's actually been done before. We have a professor, Dr. Con Wang at Iowa State University, head of plant transformation. And she specifically told us that every single modification we are doing has been done on corn before, and it's been proven successful.
One for you on the manpower side. Did you guys give any consideration into how you reduce your reliance on manpower as you evolve the concept?
Yes, we did. For our state solution, we had a team of 6 people to operate 1 UAV. However, for our national challenge, we downsized that to 4, rolling our payload and range safety operators into 1, and also having an observation pilot double as an observer.
And in addition, we don't need anybody in the field to confirm because of our modifications.
But going with a commercial camera like that also helps you a lot because it's available and proven. What drove you to the decision on that particular one? Because it seems a bit heavy for an airborne camera.
So it is not actually significantly heavier, if at all, than the X5000. And the Nikon, the brand themselves, have a very good reputation for quality and reliability. And so the D800 happens to be one of the highest resolution cameras that they make, and yet it is still cheaper than the X5000. The X5000 cost about $5,500 and only had a resolution of, I think it was around 3 or 4 megapixels. The D800 is also durable. It's a DSLR, so DSLRs are meant to be used in the field. So breaking it would be hard.
Yeah, I have a question for you. I thought your concept was quite novel, utilizing the indicator corn. Did you investigate utilizing current spectral indices that are out there before you went to that particular step to start identifying the impact?
Yes, we did. The real problem with spectral imaging is the resolution of spectral cameras, because even if we could find a multispectral camera that had a resolution on par with the X5000 or the D800, we would need to fly relatively low in order to detect any damage or anything done by the corn core. In terms of detecting the green, the phosphorescent color of the plant, the problem with that is that there are many false positives that you can get with that, because if the plant has any damage at all, it will start to change color because the health will be decreasing. So in order to minimize false positives, we decided that this was the best solution.
Right. And that just looking for the hues of green is not European corn borer specific. It is just for general plant health, and this challenge asked us to find a way to detect European corn borers specifically.
Sticking with the indicator corn, why the 17 rows? Why was come up with that number in terms of the 15 and then 2?
Because according to the way we split up the field and the way we wanted the field to look like after it has been planted, we wanted to get a very specific ratio and a very specific corn every certain amount of space. So we decided, we figured out that this was the best way to set it up.
So Vermont's a long way from Iowa. You guys did a nice job. Would any of you move to Iowa and want to study this further?
If anybody's willing to donate $50 million, we'll